Hi, Mitch here from Accurate Sound. Thanks for taking the time to view this short video on how to use the new Hang Loose Convolver application and its capabilities. Hang Loose Convolver Application and Hang Loose Convolver Embedded are two new additions to the Hang Loose DSP software suite, which is a growing suite of audio DSP applications and plugins. HL-DSP-Suite is a complete DSP solution for any audio system to perform high-resolution DSP such as convolution, crosstalk cancellation, loudness control, parametric EQ, or any type of stereo or multi-channel digital audio signal processing in an easy-to-use and flexible multi-platform software package. Let's do a quick review of the components in Hang Loose DSP software suite and then demo the new web interface and web API for embedded applications. Hang Loose Host, or HLH, is a simple but flexible application for hosting plugins. It can host any VST3 audio unit or LV2 plugin. In this example on the left, I've got 4 plugins wired in series: HL Convolver for convolution duties, Terry's Room Shaper plugin for reducing the low frequency decay time in your room, again from Home Audio Fidelity, Crosstalk Shaper for crosstalk cancellation, and from the Linux Studio project, plugin project, the LSP loudness compensator, which is a dynamic loudness control. This is just one example. Of course, there are thousands of plugins on the marketplace that do pretty much anything DSP that you would like it to do. And there is a video I've put together to show the easy way to add DSP plugins to any music app that's on my channel. HLC Plugin is a specially designed stereo and multi-channel convolver to compare level match convolution filters in real time with instant switching between filters. Whether that's linear phase, minimum phase, or mixed phase filter, the switching is instantaneous. Again, there is another video on my channel that walks through how to use the convolver and what to listen for. Getting to the new addition, HLC Application can run in its native UI mode, or it can run headless. In headless mode, HLC Application is accessed via a new web user interface from your tablet or your phone, provides easy access to evaluate room correction or headphone filters from the comfort of your own listening chair. The web interface also works with HLC Plugin. HLC Embedded is built with an HTTP server that exposes a public web interface using the Open API standard, basically a REST API. Everything that can be performed in the web interface is available through a simple web API. With the web API, it is easy for music application developers to embed convolution into an existing application. In addition to loading filters, enabling bypass, etc., a music application can signal a sample rate change to enable automatic sample rate switching for convolution, and HLC will automatically load the matching sample rate filter. We'll be showing that in the demo. Speaking of the demo, let's get to it. So for the application demo, we're going to launch the application, but we're going to launch it with the native UI running initially so that when using the web interface, we can see the live interactions between basically a client and server. We need to get the IP address where the HLC app is running. With a web browser, we'll navigate to that server address that we just got. We will activate HLC via the web interface. We'll use the audio settings dialog to select input-output devices, sample rate and buffer size, load various filters, and play some music so you can hear the convolver working. And then we'll run it headless and do a quick demo of that. And finally, we'll use a web browser to interact with the HLC plugin. All right, we're at the Hang Loose DSP software suite page, and you can order the product or order a free trial, and then you can download the product and install it. And that's what we're going to do. We're going to install, continue, agree, and install. Close. And then we're going to launch HL Convolver, the application. All right, and so now that we've got it launched, again, we're going to demo the headless operation, but for now we're just going to look at the user interface while we use the web interface. Of course, we can activate it via the native UI, but we're going to use the web interface to do that. But first, we need to get the IP address. Depending on what platform you are on, these are the various ways you can get the IP address, and on the Mac we're going to use the middle one. Okay, so let's get a terminal window, and I've cut and pasted that command into the window here. Paste. And on my machine, my IP address is 192.168.1.70. So now let's go to the web browser and 192, and we can see here that there is the web interface. I should point out that the default port for the application is port 8081. That's configurable through the command line. You just have to type in HL Convolver help, and that will show you how to change the port address. So let's go ahead and activate the product. There will have been a license key that would have been sent your way via a product purchase or free trial. Go ahead and enter it now. Now that the software is activated, your screen should look very similar to mine here, in the sense that the activation button is no longer available. We can see that the audio input has been muted. This is so that we don't have any feedback issues once we set up our input-output devices correctly. We can now start looking at loading filters and the like, but first thing we should do is look at the audio settings. For the input, I've got a variety of inputs that I can select from. However, I've selected Black Hole, which is a virtual audio loopback driver that allows me to route any audio from any application that's running on the Macintosh, or system-wide audio for that matter, and route it through Black Hole. And then the input, or I should say the output of Black Hole, will now be the input into the Convolver. And in this case, on the output, I've selected a topping E30 DAC. However, it could be any device, obviously, that you have. I've set the initial sample rate to 48 kilohertz and a buffer size of 256 samples. So the first thing with this setup is that we can kind of unmute the audio, and I should show you where that is in the native UI. You can click the audio settings button, or you can just hit the settings button and it'll bring up the same dialog. Basically, this is a mirror image of what is in the web UI. Will always be mirrored with whatever is in the actual native UI. I can unmute the input from there, or I can use the web interface to unmute or mute the input, as you can see here. The next step is to go ahead and load a filter. We just click into Choose Files, and up comes a file dialog. On this computer, I've got some demos of a single wave, a zip file with a whole bunch of stereo waves, and then, of course, the configuration file format and matching waves, so that multi-channel can also be enabled using a config file format. Let's go ahead and load the zip file, open that up, and it says that the zip file has been selected here. And then what we need to do is click on the upload button in order to upload it in the Convolver, and we'll see that it'll be uploaded into filterbank 1, which is exactly the case here. These controls are also in real time. As you can see, I can move the gain slider in real time. Double clicking on the gain slider will return it to 0 dB. And here, if I scroll down, there is a bypass button that mirrors the bypass button here. So by clicking on that, you can see that the bypass has been enabled, disabled, enabled, disabled. Here we're all set up, and now let's try and run some music. So what would be the thing we could use to demo? So why don't we try using Audirvana Studio. Okay, with Audirvana launched, let's play some music. But before we do that, I need to make one more small change, and that is because rather than having the audio go out on the topping E30 DAC, what I want to do is reroute that audio yet again to go into OBS, which is what I'm using to record this demo with, and so that way you'll be able to hear the sound. What I'm going to do is just show again that in the audio settings, you notice that the output it says E30 DAC. From the web interface, what we're going to do is select another virtual audio loopback driver, which happens to be ground control. What that means is that if I'd submit, and we can see that now the output is changed from the E30 to ground control. Again, we can just send up a single patch up to the server, HTTP server, and make that change. So now what's happening is that in Audirvana, I've got the black hole as being the output, and then the virtual audio driver routes the black hole input into the convolver, through the convolver, out ground control to channel to the input of the OBS recording software so that we can hear the audio pass through. Let's start off in bypass mode here, and we see that it's been bypassed, and then let's play a track, and then I'm just going to switch back and forth in the bypass, and we can see that it is the high frequency roll-off filter that is loaded. With the filter engaged, you'll hear all the high frequencies above 1 kilohertz get rolled off, about 12 dB per octave. We can just see that the convolver is working. So let's go ahead and play a sample track. Okay, with that, it's easy to tell that the convolver is engaged in the signal path. Let's try loading a different set of filters here. If I go into filterbank 2 and click to load some filters, let's see what we have here. And so I've got some AKG filters for a headset, AKG K371. I'm just going to load those so that we can switch between filter banks and hear the difference that it is indeed working. And the other thing I'd like to point out here as well is that these are minimum phase filters, so they have a delay of 0. In other words, the inherent delay in a minimum phase filter is 0 milliseconds, whereas these linear phase high frequency roll-off filters I have here have a latency of half the size of the overall taps, which is 65,536 taps, and so the latency is half that. But we'll notice when we do the switching that it'll be seamless. There won't be any delay whatsoever. In order to load these filters from the wave and config files, we have to load them all because this is what's going up to the server. So what I want to show is that I'm going to eliminate one of these filters to show that there's some error handling here. So let's load everything up except for the last wave file. And we're going to see that there's an error message here saying that it's missing. Please select the missing filter. We're going to go ahead and select all of the filters this time. Hit open, and we see that message going away. And now when I go ahead and upload the filters, they'll upload into filterbank 2. As you can see, the 48 kilohertz config file is the right one that's been selected since we're running at a 48 kilohertz sample rate. So now that I've got two sets of filters in the convolver, let's go ahead and listen to that again, and I'm just going to switch between filter banks this time. Okay, so as you can hear, the convolver is running, and when I'm switching filter banks here, you can tell that it's seamless. There's no delay between the two filters, even though the filters themselves have inherent delay, at least the linear phase filter does. And I've also used just the switching here on the radio buttons, but I can also switch from the keyboard. If I select filter bank 2, so the up-down arrows also work on the keyboard if you happen to be using a keyboard. All right, now that we've seen how to load some filters and use the bypass button, there's just a couple of more things I want to demo here real quick. One of them is the fact that the user interface is a responsive web design so that you can use it on your phone or tablet, and so as you expand and shrink the screen, elements will change in order to fit the size of screen that you're using. And the other thing is that, when you close Hang Loose Convolver, the reason for this button here is because you may have launched the convolver headless, where here, of course, with the window I can close it, but if the convolver is running remote and headless, we still want to close the convolver, and there's a command to do that. Allows us to save any settings. For example, we've loaded a couple of filter banks. We made a couple of adjustments like this master trim control. If you watch on the GUI, the master trim control also is in real time. Those settings will be saved when you close the convolver. I'm going to close it, and it says continue and close. And just to show that it's not running, if I refresh the web page, it of course is dead. Let's move on to the next step, and that is to run the convolver headless. All right, to run the HLC application headless, again, it depends on which platform you're running on. Since we're on the Mac, let's use the middle option. All right, let's get a terminal window. I need to change directory to applications. And just to be sure that we're not running the convolver in the background, just refresh the web page, can't be reached. And then let's paste in that command, open HL-convolver.app, tac-tac-args, tac-tac-headless. Let's run that, and we can see that it's launched, but we can see that show all windows, there are no windows. With the convolver running, let's reload our page, and we can see that we still got the high frequency roll-off filters and the K371 filters loaded, ground control, black hole, so everything's the same as we had set. And for the keen eye, some will notice that I had the trim at 5.97, the master output trim, I should say. All right, with everything running, let's play some music to run it through the convolver. And this time I'll mute my microphone so that you don't hear my keyboard clicking. Okay, as you can hear, the convolver is still running and running headless at this stage. The next step is to look at how we can also use the web interface with a VST3 plugin or audio unit plugin if you're running on the Mac. And since we're using Audirvana, we're very lucky to have the fact that Audirvana can host plugins. Let's run Hang Loose Convolver plugin in Audirvana, and let's use the web interface to switch filter banks. Let's use the web browser to interact with the HLC plugin using Audirvana Studio as the host application. While I'm using this as an example, it will work in any plugin host application. Note that port 8080 is the default port for the HLC plugin. With Audirvana Studio loaded, let's look at the property sheet and the processing configuration. Clicking on the gear icon, I've turned on audio units, I've selected Hang Loose Convolver, and I've turned real-time control on. If I press play, the convolver should come to the front. It does. There's no audio yet because there's no filters loaded. And so let's stop there and let's get the web interface up and load some filters. And here I've got on port 8080. As you may recall, when we were doing the standalone demo, it's at 192.168.1.70 on my computer. If I reload, and here we get the Hang Loose Convolver interface, web interface, and we may notice that it's just slightly different than the standalone version. There is no audio settings dialog, and that's because, of course, the host Audirvana has all of the audio settings here. And so let's go ahead and load a filter, and we're just going to do the roll-off, open, upload, and we can see that it's uploaded into the convolver. And now let's go play some music, see that it's working. All right, no problem. So we've got audio there, and let's go ahead and load up filterbank 2. And we can just use the AKG filters as demoed before. We got to select all of the filters here, open, upload, and we can see now that it's in filterbank 2. And of course, if I play, I can switch between the two via the web interface. Okay, pretty straight ahead. The one thing I do want to point out here is that on the lock icon, as you may recall, in the standalone version, there was a close the HL Convolver button, and it's not in the VST3 plugin because the host application owns that. The way that the Audirvana host works is that you need to, in order to save all of these settings, and of course it's all live as I can demonstrate here. All of the settings are live, filterbank 2 that is, and filterbank 1. Same as the standalone application, exactly the same. But in order to save those settings, we need to click the lock icon. And that puts the convolver away, and now we're ready to go and play some music again. It's as simple as that. Before we get into the Web API demo, let's talk a little bit about automatic sample rate switching. So in the case of HLC Plugin and in Audirvana or for any host application, when the host application sample rate changes, meaning that the song sample rate changes, for example, the next tune up might have changed a sample rate, then the host application will signal to HLC Plugin that a sample rate has changed, and with the new sample rate, HLC will look to find a matching sample rate filter, and if it finds one, it will load it automatically. If it doesn't find one, it will resample the filter to match the sample rate that the host player is using. This is so that the frequency resolution of the filter stays the same regardless of what sample rate is being used, and I'm going to talk about that in another YouTube presentation shortly. In the case of HLC Application, it depends on the music player application, the audio loopback driver, virtual audio loopback driver that you may or may not be using, and the OS platform that you're running on. It gets quite complicated because the difficulty comes on the music application trying to signal a sample rate chain through various other, whether it's a driver, virtual audio driver, or another application like HLC application. There's really no way to communicate that sample rate change. Along the way then, a resampler is engaged, and whatever the sample rate was set in HLC application will remain the same. That becomes difficult to negotiate, and again, it's so dependent on music app or platform and virtual audio drivers being used. In the case of Audirvana, though, Audirvana does signal the sample rate change to Black Hole, and Black Hole does signal sample rate change to HLC Application, and that works. But in order to get that to work properly, you need to turn exclusive mode off in Audirvana, and no other app can be sharing the stream, meaning so it's definitely Audirvana, Black Hole, and HLC Application, and then we'll see that the automatic sample rate does work and will change. It may not be the case for other applications or other operating systems or other virtual audio drivers. So the guaranteed way to signal a sample rate change to HLC Application is to use the Web API. And with the Web API, it's one REST API call with one parameter, which is the new sample rate that the convolver is to switch at. And so we're going to demo that in the Web API Demo, which is up next. For the HLC Embedded Demo, there's two parts to it. The first part is going to download the HLC Web API and view the documentation in the Swagger UI, and then we're going to use the Swagger UI to interact with a live instance of HLC. HLC Embedded can be run headless, obviously, in that case, but in our demo here, we're not going to run it headless. We're just going to leave it up so that we can actually see the changes on the server side. To begin the Web API demo, let's have a look at the documentation. So in order to do that, let's go to Hang Loose DSP-Suite. Let's go to the Operations Guide. And then in the Operations Guide, we will find a section on viewing the Web API documentation. And the first thing we need to do is download the Open API spec. If I click on it, this shows me the actual YAML specification that specifies the Web API for interacting with the Hang Loose Convolver instance. So what I want to do is save that as, so I right-click Save As. I've already saved it to my downloads folder, but you load it onto your hard drive, download to your hard drive, I should say. And then we go back to the Operations Guide, and we'll look at how do we actually view that. And the way to view that is to navigate to the Swagger editor, and if I open that up, the Swagger editor opens, and what it shows is the YAML specification on the left and then a human readable format on the right, and this is just an example. What we want to do is load import file, and from our downloads folder we'll open that Open API spec, open, and now we've got the Hang Loose Convolver Web API specification, stylized YAML on the left, but on the right is a human readable format that shows us all of the settings that we can manipulate with the Web API. And as I've mentioned before, the Hang Loose Web interface is using the Hang Loose Web API. So everything you see in the web interface is available through the API. And we'll just walk through a couple of documentation points here to get familiar with the API. And then we're going to interact with a live instance of HLC using the API. So one of the things that you can do is determine whether the application is running in standalone mode or if it's a plugin. In the audio settings, you can select the device type, and you can get the audio settings of the device, the current audio settings of the device, I should say, and then you can update the audio settings. And if I just expand this a little bit, it shows you what you can do for an update. You can change the input device name, output device name, whether the input is muted, what the sample rate is, and what the buffer size is. And I'll be giving a little demo of that, and we're just going to change the sample rate as part of the demo. Filterbank control, so returns retrieves the filter loaded in the filter bank with the given ID, so we can look at that, retrieve that filter. We can post a filter, meaning that we can upload a filter, and we can get the gain, and we can change the gain, And we can also select which filter in the filter banks from 1 to 6, and that allows us to easily change filter banks. And then we've got some audio parameters that we can retrieve and we can send up, and of course the license to be able to license the product. With that in mind, let's go ahead and start interacting with a live instance of HLC application. Before we use the Web API to interact with a live instance of HLC, we need to do a few steps first. The reason for this is that the Swagger UI needs to run on the local computer in order to interact with the local instance. So it's easy enough to do. Download and install Docker Desktop. It's free for personal use. Once the Docker is installed, launch the application. Then we've got a couple of command lines that we have to execute. The first one is to simply pull down the Swagger UI, and the second one is to start it up running in the Docker instance. And note that we had to use port 8888 because that's the only port that the server allows. Then we can run HLC either in native UI mode or headless mode. For the purposes of our demo, we're going to run it in GUI mode because we want to see the interaction between the API and the actual running instance of HLC. We've already downloaded the Open API spec, but what we want to do is when we run the Swagger UI from localhost, we want to import that file and navigate to the YAML spec that we downloaded and open it up. Once we've done that, we can now interact with the live instance of HLC. Okay, just to review the prerequisites, I've downloaded Docker Desktop. I've started Docker Desktop from a command line interface. I've pulled down the Swagger UI. Then I've started an instance of Swagger UI in the Docker, and then I've navigated to localhost port 8888, and in the file menu I've imported the HL Convolver YAML specification, which now is shown up here, and I've started a live instance of HL Convolver. With all that, we're ready to go. So let's walk through some of these APIs one by one and see how they work. Why don't we try the first API, which is get whether or not the app is running standalone or plugin. Given that we can see it's running standalone, this should return true. So the way that it works is try it out. And then there are no parameters to pass, so we just simply hit on execute, and that API is exercised, and we see that the response code is standalone and it returns true. So that's our first API. So the next API that we want to exercise is the get the current audio settings of the device. And so I'm just going to go over here and click on audio settings in the UI so that we can see what the audio settings are, and if we use the API to retrieve those, they should be the same. So again, we just drop down here and we want to say try it out. There's no parameters to be sent, so we'll just execute, and we've got a response code back, and so here we see what the available buffer sizes are. We also see what the available sample rates are. We see that the current buffer size is 1024, and we see that it's core audio, which I don't show on the UI. We see that the input device is black hole, and indeed it is. And we see a list of the potential devices here. And input and output channels are active. The output device name is ground control 2 channel, and indeed it is. And if we scroll all the way bottom, we see that the sample rate is 44.1 kilohertz. And so the API is retrieving the exact parameters. Let's look at the next API in the list. I'm just going to skip the patch audio settings here for just a second because I want to demonstrate that towards the end. The next thing to do is to load a filter bank. So let's try that. So let's post a filter. If I click on post and it wants a filter ID. I'm going to enter 0. 0 represents the first filter bank here, and then we're going to choose a file. I'm just going to go with the old high frequency roll-off file here, open, and then when I hit execute, should load the high frequency roll-off filter into filter bank 1, which is indexed as 0 here in the API. Execute, and sure enough, we've got the filter loaded. And if I scroll down a bit, it tells me that the file was loaded. The loaded filter file is indeed loaded. All right, let's look at the next API that we want to exercise. Why don't we change the filter gain for that filter? Here we see that I want to go to filter bank 1, which is indexed as 0 here, gain in dB. I can enter in a new value like 6.0, for example, and hit execute. And here we can see, of course, that the gain slider has been moved up to 6 dB. All right, let's post another filter into a filter bank so that we can use the ability to switch filter banks next. So we go back to our post, and we're going to try it out, and we're going to need which filter ID or filter bank ID. So filter bank ID 1 corresponds with filter bank 2 in the UI, and we're just going to choose the high frequency roll-off filters again, since we're not really going to be doing any listening. Hit execute, and there we have it. So we have now 2 filters loaded. The next web API we're going to try is simply selecting the appropriate filter bank. So here we can select the filter bank, and we're going to try it out. And it's really quite straight ahead. The only parameter is to put in a filter ID, meaning from filter bank 1 to 6 in the UI, whether it's running headless or not. And in the actual API call, it's indexed at 0, so 0 to 5. So in order to switch the filter bank from filter bank 1 to filter bank 2, we enter in 1 as an index, and then if we hit execute, we can see it switches filter bank instantly. So that's fairly straight ahead, simple enough to do. The next web API to try out is we're going to go back to the audio settings and the patch where we can update the audio settings, and we can try it out. Here we can update the input device name. The output device name is input muted, sample rate, and buffer size. What I'm going to do here is just take out these parameters, and in fact I'm just going to change the sample rate. So let's see if we can do that, and we're currently at 44.1, so let's go to 48,000 and hit execute, and we can see the sample rate's already changed. So not only is the sample rate changed in the audio settings dialog, but upon notification, HLC automatically searches in that zip file to see if there's a 48 kilohertz filter, and sure enough there is one, and it loads it. All right, let's try a few more web API calls, and this time let's get the audio parameters. So we're going to retrieve the audio parameters. We can try it out, and we're going to execute. And here we can see that the response body is bypass true. We can see that bypass is on. Master trim control is at -1 dB. And the selected filter bank index is 1, which corresponds to the visual filter bank 2 in the screen. Quite straight ahead. All right, in this last API call demo, let's set the convolver's audio parameters. Since we know what they were when we used the get parameter or get API, let's now change those and turn bypass off so we engage the convolver, the high frequency roll-off filter, and in fact let's bring up Audirvana again so that we can play that sample track and we can actually hear that it's actually running in the background and that the convolver is actually processing. Let's try it out. We're going to change is bypass to false and just going to change that master trim to, let's say, -6 dB. And so as you can hear, the convolver was bypassed, and then now it's not, and the convolver is now engaged. And that just pretty much wraps it up for our little walkthrough here on using the Web API. Note that while I'm using the Swagger editor, it's just simply a tool to exercise the API, and it's easy enough to use any kind of client-side development tools to take in the API and immediately being able to use the API in whatever client development tool that you're using. Let's wrap up with a quick summary of some things to think about. Just a few things to keep in mind about this demo. While the demo was on the Mac, HL-DSP-Suite runs on Windows, Linux, and Raspberry Pi. And for the demo, I was running in native UI mode on purpose so that we can see the interaction with the web interface and the web API. While Audirvana Studio was used in the demo, it could be any application on any platform or system-wide audio on any platform as well. Getting automatic sample rate switching is a bit of a trial and error process due to the multiple process boundaries, but as we can see in the demo, for the Web API, the surefire way is to use the Web API to signal a sample rate change to the convolver, and it happens very quickly, so quickly that it will not be noticeable. And finally, Hang Loose DSP Software Suite Operations Guide is kind of the definitive reference, so everything that you saw here in the demo is described step by step in the operations guide. Thanks for watching, and I hope you're enjoying the music.